All right. So the first thing we need to work out is you need to be able to work out is molar mass. So that I think you all did well in the test. The only thing where people got it wrong is because you can still not write a chemical formula. So what it's going to say is work out the molar mass of copper to carbonate. No, let's make it then copper 1 carbonate. So what is the first thing you must be able to do?
Write the formula.
Write the formula. So what will the formula be for copper carbonate? And I think I've said this 1,000 times in class, you can't do chemistry if you can't go from the words to the formula. Cu,
CO2. CO2.
because you need to remember that carbonate is CO3 2 minus, and therefore you need 2 plus 1s to cancel it. Okay, so otherwise everything goes wrong after this. We do mark with your mistake, but we don't want you to make mistakes in this. So when we go and work out the molar mass, remember we use a capital M for the molar mass or the molecular mass. And as soon as you see the word mass, we don't use AMU anymore. That's atomic mass units. But if you see the word mass, put it in grams per mole. That's why it's called the molar mass, grams per mole. So you're going to go, where am I going to get the molar mass from? Periodic table. So we've got 2 coppers. What's the mass of copper? 63,5. Please don't round them off. Those are already the rounded off values on your periodic table. Plus carbon is plus 3 oxygens, so it's 3 times 16, and the rest is your calculator's work. Calculator person, what is this? Yes. Stop it. What? I have.
187.
I'll show you there. Can you see I'm recording it on Screencastify? There it's recording. Okay. 100 and?
87.
And what is the unit going to be? Please, not AMU. That's someone's name. Grams per mole. So you can either write it like that, grams per mole, or write it grams per mole, but please don't mix this. Okay, so you can't go for use the forward slash and then say -1, because then you're saying divide by, which doesn't make sense. Okay, so that I think most of you got right in the test, except if you got the formula wrong. That's the first thing we did. Then the second thing that we looked at was percentage composition. Here you still don't need the mole. So if we use our formula here, the copper carbonate, so we say, okay, we have Cu2CO3, and I ask you, what is the percentage of oxygen in that formula? So you just want to know, so like you said earlier, it's like you guys can all work out the percentages that you got for your test. So we want to know how much did oxygen get for the test. So you're just going to say it's the molar mass of the oxygen in that compound over the molar mass of the total molecule times by 100. So in this case, it's going to be 3 times 16 for the oxygen over the total one that we've just worked out as 187. They're both grams per mole, so the grams per mole must cancel out, times by 100, and that gives us our percentage of oxygen. What do you get?
35.67.
Normally the paper tells you to round off to 2 decimal places. If it tells you nothing, then just do 2 decimal places, percent. Everyone happy with this still? Was this easy? Okay. The next thing we did was empirical formula, and then once you have the empirical formula, you must be able to go over to molecular formula. So here we can give you any substance. So we can say, okay, we have a compound that's made of, we like the carbon ones. I actually want to use those numbers we used earlier because they worked nicely. It was 20, 40, 40. It's fine, yeah. Okay, so we have so when they were asking you to work out the empirical formula, they're either going to give you grams or they're going to give you percentage. So they will give you grams or percentage. If they give you percentages, so they say, we've got a formula, we have C's, we don't know what it is. We have H's, we don't know what it is. And we have O's, we don't know what it is. They like using this because there's so many options for carbon and hydrogen and oxygen. Yo, now it sounds like a party. I don't know. I don't know. No. None of us know what's going on. Okay, so even if they tell you percentage, you're still going to say, okay, if I had 100 grams. So in 100 grams, oops, not mine. Welcome. Do you have a periodic table and do you have a calculator? Eddie, do you have a periodic table? Thank you. Okay, so they can either give you the grams and say, okay, this is the amount of grams you have, or they can say percentages. So then they're going to say, okay, I have 20% of carbon, I have 40% of hydrogen, and I have 40% of oxygen. But then if I had 100 grams, that would just mean that I have 20 grams of carbon, I have 40 grams of hydrogen, and I have 40 grams of oxygen. But do things react according to grams when they react? No, it's particles reacting. And how do we measure amount of particles now that you know that you're all grown up? In moles, yes. So we're going to take these and we're going to split them, or calculate the moles for each of those. And I think most of you did it like this in the exam. In the test, you split up your page and you said, let's do this for C and H and O and see what I'm ending up with. So for each of them, please write the formula down at least once because it's worth a mark. Small m over big M. Sorry, I can't kill that noise now. You just have to ignore it. Okay, so this is going to be 20 over what? What is this molar mass here at the bottom? Everyone find it on the periodic table? Do you agree that it's 12? Okay, and get an answer for me. This is going to be 40.
1,6667.
1,6667. You don't have to round. Some people wrote down like 20 decimal places. You don't have to. You can round it off to 3 or 4, but don't round this one off too much yet. Leave it. Or leave it in fraction form if you really want to. Then this one is going to be 40 over 1, and then that means that's just going to give us 40. This one's going to be 40 over 16. Work that out for us quickly. 2 point? Wasn't it 499 something?
2.5 on the dot. Because 16, 32, and half, 16 states.
Do you have a periodic table?
Yeah.
All right, now what's our next step?
Divided by the smallest number.
You divide by the smallest number. So for all of these, we're going to divide by 1.6667. Remember, you can store this in your calculator, make your life easy. Okay, now give me the ratios that you get. What do you get for C? Obviously 1. And this one? Where's your calculator?
23.99.
And this one? Do it on your calculator, Eddie. 2.5 divided by 1.66667. 1 point? Wasn't this 499?
Yes,
Okay. Now, if it's the 9 9s, you can round it off. So this one we can round off to 24. This one we're not going to round off to 2. We're going to round it off. It's either a whole number or half a number. So we're going to round this off to 1.5. But can I have half an oxygen atom? No. So when I end up with a half, you need to realize that I need to take all of them and multiply by 2 so that I can get a whole number. So this is actually going to be 2 to 48 to 3. Everyone still with me? All right, now I have my empirical formula. So I can say, fine, my empirical formula is going to be C2H48O3. I don't know if that substance exists, but it's just an example. Okay, now that's the first thing. Then, but like I say, that substance might not even exist, but it's the building block of this substance. It means that every single building block of this substance is going to have that in it. So your next step, if they then ask you for molecular formula, is to go and work out the molar mass of this thing. So you're going to say, fine, I have 2 carbons, so 2 times 12, plus 48 for the hydrogens, plus 3 times 16. I want it 120 grams per mole.
This isn't 1.4.
Okay, but now in the molecule, I might have more of these. So what they're going to say to you in the next question, they're going to say the mass of the molecule, the molecular mass, is 480 grams per mole. Hello? Do you have a periodic table? Come get one. I don't know if that's a good idea. I feel bad. I still haven't washed your sleeves.
That's fine, man.
If I knew you were going to come, I would have.
It's not me tomorrow.
Okay, now you need to see how many of these building blocks will fit into 480. But you know that one building block is 120 grams per mole. So how many of them is going to fit in there? So you're just going to divide this by 120. And yes, we're going to get 4. So to get my molecular formula, it means I have 4 of these things in each molecule. So I have to times all of them by 4. So what's my molecular formula going to be? C4H. Do it on your calculator.
If you're talking about 4, then it would be C8. 192.
I just believe you guys. Yes. It's 2 times 4, which is 8. H.
192.
192.
Oh, 12.
And O. And this now is my molecular formula. Everyone still with me? Guys, you need to stop me now if there's anything you don't understand. Yes. The question will tell you that. So the question will say to you, the molecular mass is this. What is the molecular formula? So they will tell you the 480. In the test, you had the big mass. So you will work out the small one, and then the question will give you the big one. And when you look at the small one and the big one, they must fit into each other with a whole number. If you get 2.5, you must know you've done something wrong. That means this is wrong. It has to be a whole number. Does that make sense? You're still frowning. Okay.
Then how do you do that?
So you worked out the empirical formula C2H48O3. Are you with me up to there?
Yes,
Then you look at what is the mass of that. So you go and work out the molar mass of that using the periodic table. So you know that one little block is going to be 120. Now the question comes back at you and they say, but this molecule doesn't weigh 120, it weighs 480. So then you have to see how many of these little blocks fit into 480. So you have to say, okay, one block is 120. So that means in each molecule, I'm going to have 4 of them making up my molecule. So that means I'm going to have 4 of these, 4 of these, and 4 of these. So you have to multiply the whole thing by 4. Okay. Most of you got the empirical formula right, but then you didn't or get the molecular formula right. Okay, so that's the last of the things we don't need moles for. Or we actually did use moles already. Okay, then comes the mole calculations. Now for the mole calculations, guys, there's only 4 calculations that you guys can have ever until matric. Yeah, they're going to give you one of these 4 things, and your job is to go and change it into moles. That is your most important job, and that's why I said so many times in class, if you have no idea what to do in a question, at least take whatever they've given you and change it into moles, because you're going to get 3 marks for that, always. So just do it. All right, so if they give you number of particles, this could be molecules, it could be ions, it could be atoms, it could be anything. So if you see particles, then you're going to use which equation?
N equals N over N equals N over N.
Good. And we give you these formulae on your information sheet, so you've got no excuse to use the wrong one. We give it to you. N is capital N over NA. Okay, so that's the one we're going to use. If they give you the volume of a gas in decimeters cubed, but for us, we even make it easier for you. We tell you at standard temperature and pressure. As soon as you see that, yes, Bwaga, what are you going to do?
For now, what does that N at the top stand for?
Oh, this is the actual number of particles. So the N at the top is the number of molecules, the number of atoms, the number of ions. The Na, where do you get that from? From the information sheet. And it's Avogadro's constant. It's the 6.02 times 10 to the 23 particles. But you don't have to remember it, it's on your information sheet.
So the N at the top is the number of particles.
Particles, so atoms, ions, molecules. That's it. What else could they ask you? Quarks, gluons, next year if you take a further physics. Don't all scream and say you want a cup.
Honestly, we need to go.
There are some of the grade 11s that want to do it. All right, then. Volume at standard temperature and pressure. As soon as you see standard temperature and pressure, it should wake up your brain to which equation? What did you say? That one? What did you say, Eddie?
What?
Which equation are you going to use if you say see at standard temperature and pressure? 22.4. That doesn't exist. Okay, guys, you go to your information sheet. Yes. And you find an equation that has volume. You are wrong. Because it's a gas and it's decimeters. We're looking for something with volumes in it. Volumes. Which equation has volumes in it? V over Vm. This V must be in decimeters cubed. You didn't say that. That part you're right. This molar volume, if it is at standard temperature and pressure, that molar volume is always going to be the same number. It's a constant that you find on your periodic table, on your information sheet, 24 decimeters cubed per mole. So yes, you're right. It is 22.4. Then if they give us concentration,
C equals N over B.
nice. But you must remember that they need to give you two pieces of information here. They need to give you the volume, the concentration in moles per cubic decimeters, but they also need to give you the volume in decimeters cubed. So you're going to have, if you see that you've got two pieces of information for one thing, it also guides you to this equation.
Now, so it's C equals N of B, right? So if we're trying to find B equals B, B equals C N.
Yeah, but what happens to you guys as well, exam stress takes over and the algebra fails you. So rather use the equation as it is on your information sheet because you get a mark for just choosing this right equation. If you go and do the algebra wrong, you get 0.
Yes, ma'am, but I mean, like when you're actually trying to figure this out.
Yeah, so
like,
don't do it
when-
until the
when
final
doing
step.
D distance equals speed over time. D, yeah.
I know, but do it in the last step. Don't do it in the first step. I'll show you when we do the real calculations. Because the maths sometimes make you lose marks and we don't want that. For the last one, if they give you maths, what equation am I going to use? N equals small m over big M. You'll see that sometimes we put a little r, it's relative molecular mass, but it's small m over big M is fine. And the mass must be in grams. This is the easy one that you guys are used to. All right, so that's your first step. Change whatever they give you into moles. And then we can go to our questions and calculate stuff. Okay, so when we get a balanced equation, normally we give you the balanced equation because otherwise we make our marking very hard for ourselves. So if I have this equation, what does this 2 and this 1 that isn't there and this 2 mean? Ratio of what?
Moles.
It is moles, but actually it's just particles, remember? So if you had 2 oxygen particles, they would hydrogen particles. They would react with 1 oxygen particle and they would form 2 water particles. You did this in grade 8 or something when you did particle models. Can you remember that?
And how many tissues you have?
Yeah.
There.
But it's also, if you look just around the corner, there's a box, I think, of tissues. Okay, but because you're all grown up now and you're not in grade 8 anymore, you know that this is actually a mole ratio. So it means it's 2 moles or 20 will react with 10 will give 20. So it doesn't matter if it's moles or what it is, but it's particles. So it's 2 moles of this will react with 2 moles of this, 1 mole of that, and will form 2 moles of that. Still with me? Eddie, just go like this, then I'll know you. Okay, so let's do one. So if this is the question, let's start with an easy one. So what the question is going to say is, I have 5 cubic decimeters of N2 gas reacts fully according to this equation. And we want to know what mass of NH3 forms. Okay, so we're going to do this one step by step and then we'll do some other examples. So for this one, you're going to say, fine, I need to figure out what they've given me. And what a lot of you did when I marked the tests is that you're mixing your substances. You're working with decimeters, but you're not working with nitrogen. You go and work with hydrogen or the product. And that's why I said in class, and that is why I loved your answers because you did it so nicely. You write what substance you work with. So your first job is to figure out what are they giving me and what are they asking me. So in this question, what are they giving you? They're giving you volume of what substance? Good. So they're giving me the volume of N2. This is what they're giving me. What are they asking you? They're asking you for the mass of NH3. Once you've figured that out, the rest is easy. So now, but please make it easy for us to find marks for you, because if you just go and work out a random molar mass, I don't know what you worked it out for and I can't search for marks. If you write down what you're doing, I can search for marks even if it's wrong. So we're starting with the given substance always. Yes.
I remember Schwartz was saying that since they're all gases, they're in the same ratio as the number before them.
Yeah, it doesn't matter if they're gases or not. The ratio is going to be 1 to 3 to 2. The balanced equation gives you the ratios. Whether they're gases or concentration or volumes, it doesn't matter. That ratio, 1 to 3 to 2, is always a mole ratio. Always a mole ratio.
So would the NH3 be 10 decimeters cubed?
No. Oh. But no one told you that these are all gases. So, yeah, it is right. But please don't do that in a test, because that if you use shortcuts like that, that's where stuff goes wrong. Rather go from base principles and say, it's a mole ratio. So my first step, calculate moles. Okay. Because if there's one liquid in here or one solid, that doesn't work anymore. Okay.
What are all the steps now?
We're going to go through them now. So step 1 is figure out what was given, what is asked. Then you start with your given substance. Always start with your given substance and change it into moles. So you need to figure out, I've got volume. What equation do I use to change volume into moles? Because it's a gas, and I should have told you standard temperature and pressure, V over Vm. I have the volume is 5 decimeters cubed. What is Vm? Calculator's job. Do it on your calculators, all of you. I want to see you do it.
Zero, comma, 2, 2. 0.22321428.
220.
No, 0.22321.
Okay. So for this one, don't round it off too much yet. Leave it 3 or 4 decimal places, but please don't write 8. That's enough.
8.
Yeah, some people in the test wrote so many decimal places. Okay, so this is what was given to us. Now, this is not what they're asking us. So your next step, and this is what a lot of you left out, is to go and see what is my ratio. So I need to climb over from my given substance to my wanted substance, and that is what I call the mole bridge in class. I need the mole ratio. So the ratio is always what was given to me, that N2 was given to me. What is asked from me is the NH3. And now I go and look, what is the ratio in which they would always react? And where do I get that? Sarah? Balanced equation. I know that 1 will always form 2. I don't need the 3 because they didn't ask me about the 3 this time. But you always go back to what was given to you. So the given one is 1 to 2. But I don't have 1 mole. I've got 0.223 moles. So now how do I go from there to there? If you always divide by itself, so divide by 1 times by 2. So you're going to say for this one, it's going to be 0.233 divide by 1 times by 2. If it's easy like this, you don't have to write it down.
Not 2, 3.
Now, why did you go? Why is it that formula not 1.223 over 1 times 2?
Wait, I don't know why I've lost you guys. Let's go back to here. Oh, 2, 2, 3, sorry. It's dyslexia that sets in with me, sorry. Okay, so the ratio you were fine with, it's 1 to 3. You happy with that?
1 to 2.
Oh, 1 to 2. Great. Just checking that you're awake. 1 to 2. But I don't have 1. I've got 0.223. So if this is 1 to 2, you can see easily that you're just going to times by 2. But the numbers is not always that easy. So you're always going to divide by itself to give 1 like you did for all your questions, which is perfectly fine. And then times by the one that you want. So that is why I say, okay, to get the answer, I'm going to take 0.223, waffle, divide by itself, which is 1, times by 2. Always. Yeah, because if you divide it by itself, it gives you what 1 mole would be. And then times by what you want. So you don't, like I said, you don't have to write this down, but you then use the ratio. So you're going to say divide by 1 times by 2, and that gives you the moles that you need here. I'm just going to wipe this out because I need space. You would do it underneath, please. Don't squash things in next to each other. But now I'm moving over to the givens, to the wanted substance. And I now know that my moles is going to be this. What did you get? Okay, that's almost your whole question done. Then you just go and check. Okay, they didn't ask me for moles of NH3. What did they ask me about NH3? Mass. So which equation am I going to use? Great. N equals M over big M. Now it's important that you write what substance you are working with, because what some of you did is you worked with the moles of NH3, but then you go and work out the molar mass of H2. I don't know why. Exam stress does weird things to you, or test stress. So if you forced yourself to write down what substance you're working with, you've already thought through that step. So then you can say, I have the moles is 0.446 is equal to the mass over the molar mass of what substance? NH3, which is 14 plus 3 times 1, which is 17. And that gives you your mass. Calculator's job again. The calculator really has the biggest job in this section.
7.582.
And what's the unit? If you leave out the unit, no marks. Did you do that?
Sorry?
Did you do that?
No.
So why did you?
No, I was like,
Exactly. That's silly. And sometimes we see in matric papers that people lose 6 marks in their paper just because they don't put units. You know how sad that makes me? Because we can't carry over a mistake like that. It's not an answer if it doesn't have a unit. It's so sad. I hate doing it, but we have to. Okay, guys, last thing. This was not it. Okay, the last thing that you guys learned in this chapter is percentage yield. So please, logic should prevail here, because if you... Yeah, but you went here. It's not my fault. So in this question, what we worked out is that 7.582 grams of NH3 was supposed to form. So that was your answer to question whatever it was, C. 7.582 grams of NH3 is what you got in the calculation. Then the question is going to come at you and it's going to say, in an experiment or in class or Tyrrell did this experiment and he got a mass of 6.4 grams. Now, was that what he was supposed to get? What was he supposed to get? Okay, so why some of you swap this around is a mystery. This is what he was supposed to get. That is the theoretical value. So the theoretical value is always what you calculate.
Yeah, let's put the small one on the top and the big one.
Or that. The actual yield is what you got in the experiment, in real life. So that is actual. Oh, that is not a word.
Like if I miss math, I'll catch it up in 2 days. So it's taking me 2 days.
No, if you just came to me, I'll ask Aiden how long it took to catch up the chapter when he finally actually arrived.
When did you arrive?
This morning at 8.
You told me she's coming late.
Okay, the experiment is what you actually were supposed to get. So percentage yield. What are you going to put on top? Yes, the small number, but what he actually got in class. When you did the experiment, you got 6.4 grams. What he was supposed to get is the theoretical one that you calculate. And that is going to be 7.582 grams. Times by 100. And your calculator again has the hardest job. Let it do its job.
Now, what happens if you actually look at logic and you
Then you must know you've done something wrong. It doesn't happen.
Like, let's say I was doing